All right, let's talk about something that feels like a real step change in how we build software. We're moving beyond tools that just follow commands. We're talking about tools that actually learn with us as we work. And the engine behind all of this? It's called RuvVector, and it's set to completely shake up our entire development workflow.
But first, just imagine for a second, what if your tools got smarter the more you use them? I mean, everything. Your IDE, your database, your AI assistant. Picture a tool that doesn't just do what you tell it to, but actually starts to learn your habits, anticipates what you need next, and just keeps getting better at helping you.
You see, most of our tools today, even the really fancy AI ones, they kind of work on a store and forget model. They hold information, they retrieve it, but they don't really learn from the interaction. Well, RuvVector flips that whole idea on its head. It's not just about storing data. It's about connecting it, learning from those connections, and over time, building up something that feels a lot like, well, intuition.
So let's get right to the heart of this thing. RuvVector. This isn't just one more vector database to add to the pile. No way. This is something different, a whole new category of technology. We're talking about a database that learns, and that takes us way beyond what simple vector search can do.
So what is it really? Well, on the surface, it's a distributed vector database. It stores embeddings, lets you run complex graph queries, but that's not the magic. The real secret sauce is its use of graph neural networks, or GNNs. These GNNs are what let the database see the relationships between all your data. And because of that, it's constantly learning from your queries and improving its own search index. In other words, the database itself is literally getting smarter. And if you want a really killer way to wrap your head around it, check this out. The creators put it perfectly. Think of it as Pinecone for vector search, Neo4j for graph queries, PyTorch for the AI smarts, Postgres for rock-solid reliability, and etcd for coordinating it all, crammed into a single high-performance Rust package. I mean, that's not just a tool, that's a whole tech stack in a box.
Okay, so that's the what. But how does it actually do it? Let's pop the hood and take a look inside the neural engine to see how this thing gets smarter every single time you ask it a question.
It all comes down to this really clever four-step process in the GNN layer. First, you make a query, and it finds the closest neighbors. Pretty standard stuff so far. But then, step 2 is where it gets interesting. It uses something called multi-head attention to weigh which of those neighbors are actually the most relevant for what you're asking right now. Step 3, it updates its own understanding of the data based on that context. And finally, it gives you better, more accurate results, and in the process, it strengthens the paths you use most often. It's a feedback loop that just keeps making the system better.
Now, I know what you're thinking. All this learning must be slow, right? Nope, not even close. The median search latency is a jaw-dropping 61 microseconds. That's not just smart, it is blindingly fast. We're talking about a system that can be over 150 times faster than some other search methods out there. It's wild. Let's actually put that speed into perspective. Take a look at this comparison with the big names: Pinecone, Qdrant, Milvus. The latency numbers just speak for themselves. 61 microseconds for RuvVector versus milliseconds for everyone else. And look at the memory, 200 megs for 1,000,000 vectors. That is 5 to 10 times more efficient, all thanks to some slick auto-compression. It's on another level.
But performance is only half the story. This is where things get really interesting. We're talking about features like native graph queries, actual self-learning with GNNs, runtime adaptation, even routing for AI agents. Look at the chart. It's just a sea of red X's for the competition. These aren't small upgrades. These are capabilities the others just don't have. This is exactly why we're saying it's a whole new category.
And to top it all off, let's talk architecture. It's built like a tank for scale and reliability. You've got raft consensus, multi-master replication, all the serious enterprise stuff. But the kicker, the thing that really blows my mind? Full browser and WASM support. Yep, WebAssembly. That means you can run this entire learning engine right in the browser, client-side, even if you're offline. That mix of heavy-duty systems and ultimate flexibility, you just don't see that anywhere else.
So we've established the engine is an absolute beast. But a powerful engine is only cool if it's powering something amazing, right? So let's shift gears and look at the Flow Claude workflow. This is where we see how this learning database actually creates an AI assistant that is genuinely, noticeably smarter.
And this is where the magic happens. RuvVector has these things called intelligence hooks, and they plug its brain directly into the Claude AI assistant. What this does is give Claude a memory, an intuition.
It suddenly understands your code base. It remembers what worked last time, it learns from the bugs it helped you fix, and it starts to get good at guessing what you're going to do next. This completely changes how you interact with your tools. The new golden rule is simple. Just ask. If something's broken, you don't have to spend an hour debugging. You just ask, hey, why isn't this working? Can you fix it? You're not issuing commands anymore. You're having a conversation with a partner that actually has context and remembers what you've been doing.
So what does the project look like in this new world? Well, it kicks off with Claude basically doing the research. It sucks in all the project context and requirements. Then, using all the patterns it's learned over time, it actually proposes a full architecture for you. And for the implementation, it unleashes a swarm of AI agents to build it, while RuvVector acts as the traffic cop, routing tasks and making sure the system learns from any hiccups. It's this continuous cycle of learning baked into every single step.
Okay, let's pull back for a second and look at the big picture here. What we're really witnessing is a whole new paradigm for development. We're moving away from static, dumb tools and toward dynamic, intelligent partners that actually learn and grow right alongside our projects.
So what's the bottom line for you? It means you get an AI assistant that actually remembers things. It learns from its mistakes, just like we do. It means your code search gets better and faster automatically, without you lifting a finger. It means you can hand off really complex stuff to a swarm of AI agents that know how to work together. And at the end of the day, it all boils down to one thing. You spend way less time on boring, repetitive tasks and way more time actually building cool stuff.
So I want to leave you with this final thought, because it really gets to the core of what this all means. When our tools stop being just tools and start becoming partners that can learn and anticipate what we need, a whole new world of possibilities just cracks wide open. So the real question is, what will you build when your tools can learn?